In this video we're going to take a look at this little power supply that failed. This power supply was used to power up a small desktop radio, and it literally had been sitting in the box unused for a better part of 5 or 6 years. And took it out a few days ago and plugged it in, and within just a few minutes of plugging it in I heard a small muffled pop and then a muffled sizzle type of sound. Now the radio was still working, but as I touched the power supply it was really warm down in one corner. So I knew that something went, and most likely a capacitor failed in it. So I took the cord off and hooked it up to another power supply to run the radio, and I was about to toss this in the garbage, and I thought that, well, it might be fun just to look inside and see what was in there, and see what, like many of these little power supplies like this, they're glued shut, and basically the case is in two halves. Sometimes there's little feet that you can take out, little rubber feet that'll pop out of some indents, or pull them off where they're glued on, and there might be a screw underneath those or underneath the label here. But this one is just simply glued shut. In fact, it doesn't have a name brand on it, just made in China, but a model number, but no manufacturer. So and it's pretty heavy. You can see it's a 120 volt 500 milliamp in, 12 volts, and an amp and a half out. So it's a pretty good size power supply for as far as these little wall wart type things are concerned. But it's reasonably heavy, which tells me it's not a switching power supply. It probably has got a good sized transformer in it and just a linear supply. So so let's open it up. This one is glued shut, as I mentioned. There's no screws on it. So one thing you could do is you could slice along the seams here to try and open it up if you're going to reuse it. But since we're not going to reuse it, you can often just pop these seams by whacking them with a hammer. Just like that. Alright, so with the case cracked open, literally, we can just open it up and take a look at what we have. And, well, really no surprises. Pretty cheap power supply, not regulated. We take a look, we've got the power transformer, and as I suspected, a pretty good sized transformer. So certainly a linear supply, and all of 5 components. Okay, we've got a 4 diodes, so it's just a full wave bridge rectifier and a filter cap. And I can see from here right away that the cap went bad, and that's what popped on this thing. And how can I tell? Look really carefully at it. You can see the top of that capacitor is domed. Let's see if the camera can kind of pick up the fact that it's kind of arched up and domed. So the cap overheated and overpressured, bellowed the top of it there, probably blew out the vent hole at the bottom of it. We'll pull it out and take a look at it. But that's what I heard pop, and probably sizzling, and what was getting warm when this thing was operating. Alright, with the whole power supply out of the case, we can again see that capacitor is bulged at the top. Just the 4 diodes for the bridge rectifier. So we can very simply try to pull this cap out of here, grab my soldering iron, and I should be able to just lay the iron across both these leads and drop the cap out of there. So so there we've got the capacitor out of there, and it's interesting, I don't see the vent hole blown out of the back of this thing, but it may have blown elsewhere. But this is pretty clearly bulged here at the top, and where the problem lies with this power supply. But let's go make a couple of measurements on this thing. All right, let's start off by measuring capacitance. It's a 2200 microfarad capacitor. Hopefully you can pick that up there on camera. Now with a capacitor that large, it does take a while for these meters to register the capacitance value. So let's see if I can get the leads on here and hold them on there long enough for the meter to respond. And you can see the meter's kind of going through its ranges. You can see how the decimal point is moving. And well, this is registering 1941, 1960, so just under 2000 microfarads. So that's actually pretty close, and probably within tolerance of this really cheap capacitor here, this Econ brand capacitor. But we know it's bulged, so it overheated. Let's take a look and see what the ESR is. Alright, we'll just use my homebrew ESR meter here to measure the equivalent series resistance of this capacitor. First thing I'll do is I'll just short the leads together here and zero the meter. You can see I just made my own scale on there, so there's 0, there's 5 ohms, 10 ohms, 20 ohms, and we can kind of watch the meter. There might be a little bit of a parallax error the way I've got the camera set up here, but it should still be sufficient. A capacitor of this value, should read pretty darn close to 0, or less than 1 ohm. So let's hook up the negative lead to the negative side, the positive lead to the positive side, and we can see that I'm getting just about 5 ohms of equivalent series resistance, and that's way too high for this capacitor. So that certainly is what failed, and most likely what caused it to overheat. Excessive power dissipation from the ripple current, and the thing just popped. So anyway, I thought that was a short, interesting little video on this really cheap power supply, and I'll tell you, I feel lucky that I was standing there when it popped, because it got quite warm within a few minutes, and if I had walked away with this thing plugged into the wall, it might have burned up or started a fire or something like that. So I'm really kind of glad that I caught it. And the unfortunate thing is that since it's brand new but sitting in the box for 5 or 6 years, I can't go complain to the manufacturer of the radio, because it's certainly past the 1-year warranty period, even though it had never been used. Anyway, I hope you found this video interesting, and I'll talk to you later.